Good morning, everyone. I want to start and thank TIPE and Women in 3D Printing for putting on this amazing event. I feel like so often we get stuck in the tunnel vision of what our companies are working on, and it's really energizing to see what other people are doing in this really quickly evolving industry. And I want to thank them for having me this year to talk to you about the trends in 3D printing that I believe are going to help us move towards greener manufacturing. I'm Izzy Guardia, and I'm a senior design and development engineer at FastRadius, which is a cloud manufacturing company with substantial capabilities in industrial grade additive. So why I'm here, a little context. In college, I majored in manufacturing and design engineering, gearing up for a career in product design. And in my junior year, I studied abroad in France for a semester because I had been studying the language for a few years. And for some reason, given the course equivalencies, I had a really light course load, which left me with way too much time on my hands, which doesn't sound like a bad thing in Paris, right? But I don't know what got into my head that I was like, I need to do more stuff. So I decided to take an extra course online and went to the EDX website, which a colleague had recommended to me, and somehow wound up taking this course, Circular Economy and Introduction, that was offered by TU Delft in the Netherlands. And that course completely revolutionized the way that I thought about product design and manufacturing. And to explain, let me back it up and actually define what the circular economy is. So today, our economy is designed in a very linear fashion in which we extract materials, make them into products, and then discard them at the end of their usable life. In contrast, a circular economy aims to create a more sustainable ecosystem through a systems focus and restorative approach, whose key goals are to maintain the value of resources for as long as possible and to eliminate sources of waste in the system through the superior design of materials, products, and systems, in particular, our business models. So, for example, on the blue side of this butterfly diagram, it shows the many paths to extending the usable life of a resource or product, including maintenance, redistribution, refurbishing or remanufacturing, and recycling. And so what I realized through the different case studies in the course is that sustainable design is just more efficient design. It's taking an additional set of design objectives and reimagining new ways of doing things outside of our current systems, which also changed the way that I thought about my personal habits. I started to realize that every time I got a to-go cup of coffee at Starbucks, I was directly responsible for that plastic lid entering the ecosystem for the next 500 years or so. So I started dipping my toes into the world of zero waste living, where I started making small swaps in my daily life to reduce my personal impact, like carrying a collapsible coffee cup with me. Or unintentionally, I ended up with this thing behind me that was a large IKEA mirror that actually fell over and shattered. And I decided, I was like really in the thick of it, and I was like, I'm gonna make an art piece out of it. So that's my weird background right now. But fast forward, I graduate college and I end up at FastRadius. FastRadius is a manufacturing and software company that's focused on bringing our industry into the digital age. We make industrial grade parts for companies in industries from aerospace to automotive to medical, using both additive as well as traditional technologies. And as a design and development engineer, my focus has been using the additive expertise that I've developed to help customers make products in new ways, which means that I work primarily with 3D printed plastic parts, which sounds really sustainable, right? But so the job was a great fit professionally in terms of my degree's relevancy, but it caused a lot of cognitive dissonance. And the truth just is manufacturing has a huge environmental impact. Research from the World Resources Institute shows that industrial activity, which includes manufacturing, accounts for 24% of global greenhouse gas emissions. And in the US alone, the EPA estimated that 7.6 billion tons of industrial solid waste is disposed of every year. But it's not all doom and gloom. We can't just not make things. And the more I came to understand FastRadius's vision, the more I realized how big of an opportunity 3D printing plays in greener manufacturing. So yes, I'm working at a company that manufactures plastic parts, but plastic isn't going anywhere anytime soon. So it's important to start redesigning our processes and our systems to start minimizing that waste in the near term. So where do you start? There are many opportunities across the product lifecycle to reduce your company's environmental impact. And for this talk, I'm going to focus on two key sections, which are how to design and how to make more sustainably. So starting with design, to put it simply, less is more. A lot goes into making a product, and as demonstrated in this diagram, there's energy and resource use associated with extracting, transporting, and processing raw materials, manufacturing and packaging a product, shipping it, using it, and finally disposing of it. As designers, we should strive for maximum efficiency to reduce the resources that are depleted along the entire life cycle. And additive has a few advantages in this regard. To start, additive is an inherently low waste process, as you're typically using just the amount of material that you need, especially when you're able to eliminate support material. Some technologies do require excess material, but in many cases, it can actually be reused in subsequent prints. So for example, carbon digital light synthesis, which is pictured on the left, you typically have liquid resin left over in the cassette after the print, but if you plan your prints well, you can reuse it for the next print to minimize waste. And similarly, HP multi-jet fusion that we use a lot, pictured in the center, you're creating a large build full of loose powder that has, parts printed inside of it. So you always have a lot of excess powder at the end, but HP has actually made a large strategic push to be more sustainable, and they've specifically worked to increase the reclaim rate of this powder. It's up to about 80%, I believe. So you can remix that used powder with the next batch with some virgin powder to increase the reclaim rate and keep using that powder. And anything that's not recaptured can actually be sent to HP for recycling. So even when there is waste, there are certain processes that you can implement to minimize it. Additionally, additive lends itself to lightweighting. And of course, this isn't unique to additive. There are techniques you can implement in injection molding, machining to reduce material in your final product, but the increased design freedom in 3D printing allows us to make use of new techniques such as generative design, which is pictured on the left, and latticing, so you can reduce material even further while maintaining performance. Not only does this reduce material, but it can also reduce the energy associated with faster print time, as well as the emissions that are associated with the shipping of the product and the weight of that product. This will be more dramatic for metal printing, but you can still see gains over time with plastic. And you shouldn't just stop at your part either. At Fast Radius, we actually use particularly lattices very frequently to lightweight fixtures that we're going to use for baking, assembly, and inspection. And that's not just within our additive microfactories, but we'll also print fixtures to be used with CNC, for example. So those benefits can extend beyond just additive, making use of 3D printing for the fixtures. And there's some amazing software that allows you to design these complex structures, as well as run simulations so you can ensure that you're hitting that right balance of material reduction to performance, such as Topology, which we use very frequently, or Fusion 360 has some generative and simulation capabilities as well. So it's important to become familiar with these tools so you can start to reap these sustainability benefits. Similarly, increased design freedom makes it easier to consolidate separate parts into a single component. For example, the pump impeller on the left is typically made of several metal components that are welded together, but you can print it in one shot using 3D printing. And the image on the right is from our case study with Steelcase, in which we consolidated several different pieces that are typically assembled into a single 3D printed armrest. And the reason this matters is because part consolidation has the potential to reduce overall material usage, as well as machine time. And also, more importantly, is eliminating the shipping that's required to ship subcomponents from suppliers all over the world to one single point of assembly. Another thing to consider is how nestable your part is. As you can see in these sketches, a slight design tweak can make it so that parts sit into each other, taking up less space when stacked. If you can design it to pack flat or nest efficiently, you can fit more into a build, which on one hand will lower your part cost, but also it'll lower the energy associated with the machine time, and also the emissions from being able to ship it more efficiently. Next subtopic is designing to last. One of the key tenets of the circular economy is to maximize the usable life of a product, so that you don't have to make more products and that you can keep it out of the landfill. So it's important to design for durability and serviceability, which means designing assemblies so it's easy to diagnose failures, replace components, and access areas that are in need of service. And this is where a little bit of discernment comes in, because as you recall, I just mentioned that there's some environmental savings that can be associated with part consolidation. But on the other hand, it may impact serviceability if you make one big mega component and then service a small part of it. You now have to replace that whole component as opposed to just like the smaller subassembly. So it's really important. This speaks to, within designing for sustainability, taking a holistic approach and balancing these competing factors and really taking it on a case-by-case basis. Perhaps one of the most important decisions, which you might have the least control over, is what you make your parts out of. Since additive is a relatively young market, some technologies might be limited in their material selections. But in general, you can think of three things when evaluating material, which is, first, what is the source? Is it bio-based, petro-based plastic? Is it renewable or finite resource? And is it a virgin plastic, or has it been mixed with a recycled material? Secondly, does it contain any known toxins? There are standards such as REACH and RoHS, which is the EU's restriction of hazardous substances directive, which can help you find this information. And lastly, what happens at the end of the life of the material? Is it compostable or recyclable, or does it go straight to a landfill? Even though there are many plastics that are technically recyclable, PET and HDPE are the only ones that are regularly recycled. So, and it's estimated that only 8% of plastic actually gets recycled. So looking for biodegradable options where possible is preferable, of course. And even within that, not all biodegradable plastics are created equal. So PLA, for example, only decomposes at commercial facilities when it's heated to 136 degrees. So it won't just decompose in your backyard, So it's critical to not only choose better materials, but to ensure that you're labeling your products properly, to ensure that the consumer is empowered to dispose of them in the correct way. Luckily, there is a lot of innovation happening in the space, particularly in 3D printing. A couple examples on the screen. First, you have Forest, which is I'm excited about. They were recently acquired by Desktop Metal. It's a binder jetting system that adds, instead of the powder, they use reclaimed sawdust. And instead of the binder, it's actually a bio-derived lignin to create wood parts. And then you have a Frankel that's actually making filaments out of like oysters and wheat and coffee. And then you have companies like Filamentive that are creating filaments from recycled plastics. So where possible, it's good to try to incorporate these, even if it's just in prototyping, to promote this development of these materials. And we really do need to be moving faster on the material side, so it's important to put pressure on your material providers to produce more sustainable materials. So next subtopic is, it's not just about the final product design. There's actually many savings to be had in the design process itself as you prototype that can really add up over the long run. So additive allows you to prototype in low quantities without having to worry about cutting tools and minimum order quantities. And additionally, you should consider printing earlier concept prototypes in more sustainable materials until you need to start testing the production material. And before you can even get to printing, you should try to prevent the creation of scrap parts to begin with by making use of simulation software and virtual builds to catch issues before sending the design to production. So taking time to validate your design virtually by carefully inspecting the assembly. CAD and like tools like Fusion and SolidWorks have tools that allow you to review things like wall thicknesses and interference to catch errors before you even hit print. And similarly, using additive prototypes prior to injection molding can prevent the waste that's associated with additional tooling and prototype runs, and be able to just like test your design more before you go to production. So now that you've designed a sustainable part, how do you actually reduce the impact of making it? As 3D printing grows, so does clean energy. So you should look into your energy provider to see if you can source cleaner options or even install your own solar panels or wind turbines at your manufacturing facility. And you can also try to reduce your overall energy usage by optimizing your machine time, your incorporating smart outlets, light timers, efficient light bulbs, etc. One of the biggest opportunities for modern manufacturing is creating a distributed network of microfactories closer to the point of use. So in partnership with ERM, we actually modeled this to understand the potential impact. And in the first scenario, we model it where Fast Radius produces all of their parts in Chicago and then ships them to Seattle, Dallas, London, Singapore. And in the second scenario, we modeled adding local regional hubs on the different continents. And seeing, such as LA, Germany, and China, and seeing the potential impact. And what this does is it eliminates the long transport legs by air, which is the highest source of emissions, in favor of either shorter plane rides or primarily ground transport. And our modeling should suggest that this can reduce emissions by 83%, which is really significant. And along with eliminating the need to ship parts, cloud manufacturing can reduce the need to keep physical inventory in massive warehouses. With additive, you don't have to have minimum order quantities. So instead of producing thousands of spare parts that sit on a shelf for many years and ultimately become obsolete and end up in landfills, you can store the part digitally and print it where and when it's needed, which means you can support old programs for longer. You don't have the cost of keeping it in a warehouse, and you'll actually be cutting back on all the emissions associated with running the electricity, the water, the HVAC of these large buildings. And my last food for thought is to consider your shipping materials. Plastic shipping tape and bubble wrap may be the norm, but there are actually many alternatives with lower environmental costs that are also cost competitive, such as compostable air pillows, recycled paper filler, and for more custom needs, instead of turning to thermoformed like clamshell or blister packaging, you can explore using bio-based molded packaging. So such as this mushroom packaging that's pictured on the right from Ecovative. It's a technology that came on my radar recently, in which they actually use a mushroom mycelium network that grows into hemp herds in a custom mold that's then baked, and it's fully backyard compostable, but its shelf life is still around 30 years, I believe, because it only starts to decompose when it's exposed to nutrients in the soil. So there are countless alternatives that are worth exploring, from cork to cornstarch, and more companies are popping up to commercialize these regenerative alternatives. So whether you work in product design, material development, manufacturing, operations, logistics, you can start to work a circular mentality into your skill set and learn to factor sustainable considerations into your work, so that if we all start to make better choices, big or small, we can take advantage of the advancements in 3D printing and cloud manufacturing to start to move the needle forward towards a circular economy. Thank you, everyone, for your kind attention. If you're interested in connecting further, please feel free to reach out to me on LinkedIn. And I think it's time for some questions.
Yeah, thank you, Izzy. That was so important, I think, to the conversation, and it looks like you've done so much work on the circular economy and sustainable initiatives. I think you hit on a lot of good topics. There's a couple questions here for you that I'd love for you to answer. How do you identify good opportunities for part conversion to AM when a company is green focused?
That's a good question. So how to identify good opportunities for part conversion? I think a lot of our good applications come around the kind of volumes you're looking at. So a lot of times, historically, if you're going to go to injection molding, it's like a lot of our cases, you kind of are tied into certain, like what I said, minimum order quantities. So you want to start prototyping, you have to cut a prototype tool, and then you can run all your parts through the life of your program. And at the end, for spare parts, you again need to keep these large parts sitting in inventory. So 3D printing is really good as well, like commercial 3D printing. Although it can be a standalone production method, it's also really good as like a ramp up to and down from production. So in those early stages, when you're selling lower volumes as the product is ramping up, using 3D printing to prototype, which you can prototype in an actual like production material, and then using 3D printing for like the early volumes as you ramp up to those minimum order quantities, then converting it to injection molding for when you're selling those higher volumes. And then at the end of the life, you can switch back to that validated 3D printed version of the product so that you don't have to be storing these spare parts, and then it can live like in the cloud, and then you can print them and send them to customers on demand. So I think that's a really good kind of archetype of a place where you can have a lot of savings. Yeah, and then I think a lot of it, like I said, comes from like design choices, like how can you minimize the material and just make the manufacturing as efficient as possible, have efficient builds where you're squeezing in all the parts and reducing the overall waste associated with the process. And then I think there's kind of working with a partner that's has sustainability in mind, and even if they're not fully there, they're starting to look at how can I use more green energy, how can I reduce my waste. It's like kind of looking at little things along the life cycle that it really starts to add up.
Where do you think open source material platforms fit into sustainability with AM? Do we need more? Are they a priority? What are your thoughts on open source material?
I'm definitely a fan of open source. I think it creates more opportunity, more competition, and allows people to innovate across the marketplace. And maybe, if they come up with a solution, they can apply it to different platforms. And I think that's what we really need in AM is a lot more material development, particularly on the sustainability side. I think we've started to see, I read a research paper, maybe from MIT, I'm not sure, that they've actually found a way to start recycling thermosets by like adding some additive. So I think like that's what we need to start see happening, and then like turn into a commercial material. So I think open source platforms only enable that by allowing more innovation.
Yes, agreed. Next question is, how significantly can replacing IM parts with AM parts reduce the overall waste on a project?
Yeah, I think it's a good question. It's difficult to answer in the abstract. Like I said, you really need to take a holistic approach. Actually, similarly, Sherry Handel from the AMGTA, like they did a whole research paper specifically in the case of metal, and the outcome of their like comparing, I think, a metal additive to CNC, and their outcome was like it's really case dependent. Like sometimes it's better, sometimes it's not. And they did a very complete life cycle analysis. I think it would be the same thing for plastic. It would depend on what parts you're printing, what are your volumes, like kind of what would it look like without additive, and then what would it look like with additive. So it's hard to answer in the abstract, but I think it's, like I said, finding those opportunities for cutting back waste in the development process, the end of life, etc.
In your role at Fast Radius, do you have an opportunity to I guess push or evangelize more sustainable options for your clients, or is it more the clients pushing the OEMs or the manufacturers, the service bureaus towards sustainable materials?
I think it's a mix. And for it to be successful, it's really going to take everyone pushing for it.
Yes.
We need a lot of development from like our material providers, for example, and our OEMs of the printers that we produce. There's a lot that we can do and are starting to do. I know that our leadership sees sustainability as kind of critical to any successful business going forward in this day and age. There are people across Fast Radius that are interested in it, like from everything from sales to marketing to engineering, where I sit. And so I'm actually leading kind of like an internal effort where we're working on different development projects to make improvements across the chain. So there's a lot of, I guess, cultural interest within Fast Radius, and at the leadership level, I think we're still working on how to kind of formalize that more and make it a growing part of our business. And then I think we are starting to see it from customers. Like I've talked to different customer application engineers who come to me and say, oh, actually this customer was looking for, more sustainable injection molding material or something of that nature. So we see it popping up at different points of our business and different like partners that we interact with. And I think, for customers to ask about it then shows like us that we need to work on it more, and then we need to put the pressure as well on our OEMs and our materials providers. It's really going to take everyone, I think, to move it forward.
Yeah, yes. There's a lot of great comments in the chat that I encourage you to take a look at. And then just a final question. Where would you suggest a company start, in their sustainability or implementing a circular economy? because you're right. It's a holistic approach, but where would your advice be on how to start, like today, building those internal initiatives or for a project?
Yeah, I would say first and foremost, it really needs to come from the leadership level. Individual contributors can make differences, and I'll speak to that in a second, but it's hard to push for it just at an individual level if there's not a coherent strategy around it, because you'll hit walls, you'll get demotivated quickly. So it's difficult to have forward movement unless it's coming from the leadership level, and they're really finding how to trickle it down to the IC level. So when I was interviewing some of our customers around sustainability for a little research project, that seemed to be one of the biggest gaps. Is even companies that did have sustainability strategies, like it was talked about at like the high level, but then the ICs, like the individual contributors, were not sure how does it actually play into like my work, and how do I evaluate an economic concern against a sustainability concern, and do I have the power and the support to choose sustainability over economics in some instances? Like how does it actually play out in your day-to-day job is really important. So if you are in the leadership level, figuring out how do I actually trickle it down in a way that is actionable. And then from the IC level, I think, that's how I started when I started to have my conflict of interest realization. I made an environmental task force. I got people involved across the company. And then kind of now that it's gaining more momentum at the leadership level, we're starting to synchronize those efforts. And so just kind of by spreading culture around it, kind of making an interest group, you can start to kind of lobby internally and just get it on people's minds and make it more a part of the culture. So then it gets traction kind of when the leadership level catches up, or vice versa. So it can happen from both levels, but I really do think that the kind of having a coherent strategy as a company is super important.
Yeah, that's amazing that, I think from both points, yeah, but that you sort of had this realization and then, pushed it in your own actions and throughout your company. So congratulations to you.
Thank you.
Thank you for your work, and I look forward to seeing more of what you do with that and run with it. Any final questions for Izzy? You can put them in the Q&A section of our chat here. But I'm sure you're going to be in the conference. I know you're speaking in some other presentations, so catch up with her in the networking sessions and see her other panels at TIPE today. Thank you so much.
Thank you. Thanks, everyone.